Hi everyone, I hope you had a great spring break. I'm just at the end here trying to get some things together for you before you take your exam on May 22nd at 2 p.m. So I know we had a couple lessons left to learn and we did that before spring break. If you didn't do any of that work, I recommend that you work through those videos and do the assignments in my AP to get some practice. But I did want to take some time today to go over our plan for the next couple of weeks and also to just show you one quick thing about linear regression to review that in a video form and to show you one last thing about it. So my recommendation for today is that you print the document on the website or on the Google Doc, wherever I put this, so that you can follow along. Then watch this video. You should already be watching it as I show you what computer output is and review some linear regression material. Then we're going to complete the diagnostic test and stats medic review course. It's 30 questions, and then print and work through the analysis. The work that will be very quick. It's just recording what you got right and what unit it belonged to, and then answer the discussion question at the bottom of the page. That way I can just see how you did and what you need most help with, and I can reach out to you and help you if you have a lot of issues. All right, so what we're going to do is move on to the first page in this, the next page in this document, and this is an example of an FRQ from 2011. I'm going to zoom in, it's a little small. Okay, so when we read through this at the beginning, windmills generate electricity by transferring energy, blah, blah, blah. Keep on going. We always want to highlight some important things when we look at FRQs. And so we have the relationship between wind velocity in miles per hour and electricity production in amperes. And so we don't know which one is X and which one is Y yet, so we're going to keep reading. For the windmill, measurements were taken on 25 randomly selected days. Gotta have that info. And the computer output for the regression analysis for predicting electricity production based on wind velocity is given below. So what that means is, I already know, it's really large. Let me just undo this. I'm going to be typing on here, so bear with me as I do some of this stuff. X equals wind velocity, and Y is going to be your electricity production. We know our units are very important. The wind velocity looks like it's going to be miles per hour, and this electricity production is amperes. So I like to identify that kind of stuff in the beginning. I'm going to put this in blue. I like to stick with my routine. And then I'm just going to write that down from the information and then keep reading. The regression model assumptions were checked and determined over the interval of wind speeds. Okay, great. So now what we have right here is in this box is called computer output. So I am going to turn this to red and we're going to label computer output right here. It's got a lot of things. First of all, we have predictor, constant, and wind velocity. Notice how I wrote x equals wind velocity and then it says wind velocity right here. What that means is that this row, whatever they have written here, is your x. And that's always the case. So we're going to put that right there. I'm going to make this a little smaller. So we have our wind velocity is the x. Whatever is in this word right here is your x. So if you can't figure out from the paragraph which one is x and which one is y, look at this computer output and they'll tell you. And the odds are on your exam this year that they would have a computer output more than any other kind, since it should be something that you don't need to use your calculator for too much. Pencil and paper calculations is what they've said. Constant is a number without a variable next to it. And so the coefficient for the constant, the number without the variable, that's going to be your A. So this whole entire row is all about the y-intercept. And then this whole row is all about your slope, because it's the coefficient in front of x. That's the b. When we look at the equation y equals a plus bx. So b is right here. So it makes it very easy to write the equation for the least squares regression line, because they give you the A and the B right there, and that's all you need. And we'll get to that in 1 second. This A row, we'll never use any of that, so we're going to cross that off. And then the B, we would have used this row before your exam, before this whole pandemic situation, and we would have taught it to you, but not on your exam, so we won't need it either. But the T is the test statistic, and the P is a p-value, and that's the standard error. So we've learned all that kind of stuff before. So I'm going to cross that one out in black. We don't typically cross it off, but we will this year. And then we will never use the R-squared adjusted. But we did learn about S, standard deviation of the residuals, the other day right here. And this is your R-squared. So if they give you R-squared, you know, that's really R to the second power. And then it's one of your things to interpret. And then if they want the R, the correlation, you could just square root that. Okay, so A, use the computer output above to determine the equation of the least squares regression line. Identify all the variables used in the equation. All right, well, I'm typing, so I'm just gonna write I'm gonna identify the variables. Let's see, I'll just write y hat equals, make it blue. I don't want to put the hat. You would write the hat, you would draw the hat. Okay, y hat equals A, which I identified as 0.137, plus B, which I identified as 0.240 x. And then I'm going to define x as wind velocity and y hat as predicted electricity production. All right, so you have to define your variables when you write that down. So I would just use the caret if I wanted to. On your exam, you will be able to take your stuff and take a picture so you can use your handwriting and you don't have to type a hat. So we got a y hat, y hat. All right, let's just look at a couple other questions. I don't want to do too much of this, so you have a lot of other things to do. How much more electricity would the windmill be expected to produce on a day when the wind velocity is 25 than on a day when the wind velocity is 15? These are just two different x values. So for this, I would just plug in 25 for x and then plug in 15 for x and then subtract. I'm not going to worry about doing that, but the answer is 2.4. So I'm just going to show you how I would do it. I'm going to say y hat equals 0.137 plus 0.24 times 25. And then we'll do it again. 137 plus 24 times 15. And then we'll subtract whatever those two answers are and get 2.4. And you have to write the units to get it correct. I remember that from when I've done this question before. So I'm just going to do a big old minus right here. Well, it's not that big, but I'm going to put it right there and then put this in parentheses or bracket. All right, so that is how you get 2.4. All right, moving on. I only want to show you one more thing. C, what proportion of variation in electricity production is explained by its linear relationship with wind velocity? That is your R squared. You need to know that. The only thing that was most important about what you guys learned before spring break is this interpretation flashcards. And so that is R squared, and that's going to be 0.837. Like you can see it right there in the problem. It says R squared already. So that's an easy one to answer. So my mouse. Okay, 1 second. Let me scroll back up. R squared right there. And then D, is there statistically convincing evidence that electricity production? That is not on your exam this year. That is from the unit that we don't have to learn because they cut out 25% of the material. All right, so that's pretty easy. I'm just going to show you one more just to show you the computer output and how easy it is. And so here we have blah, blah, blah. Doesn't matter what all this says. Well, it does, but most importantly is that we know X is right there. Customers in line. You can also see that from the scatter plot. That's the X-axis. And then we have the Y-axis. I should really just be typing. I'm obviously very bad at this. Okay, let's do X, and then obviously the time is your Y. So That's easy to see from the scatter plot. And also don't forget though that this computer output shows us X and Y. And so A, identify and interpret the context, this intercept. That's the Y-intercept that they're asking about on this problem. And so I can see that right there, the Y-intercept, this is always the case. A, 72.95, B, 174.4, and then so I'm going to say the Y-intercept A equals 72.95. We predict the wait time to be 72.95 seconds when there are 0 customers in line. That is one of your flashcards. Is just an explanation for what the Y-intercept represents. We look at the next one. Identify and interpret the coefficient of determination, R squared. So that's R squared right here. That's just one of your flashcards. I'm going to cross these off so we don't have to cross the adjusted one off. And so it's 73.33%. So we're going to say 73% of the variation in the Y values. So I'm going to say seconds spent waiting in line is explained by the linear relationship between seconds and number of customers in line. And then this last one says one of the data points was an outlier. Circle the point and explain why it's an outlier. And so the outlier is going to be the one that is the furthest from the line with the largest residual. That's this one. Oh, wow, it's a terrible circle. Let's try it again. This one. And so then what I would say is there's an outlier when at 3 customers in line because they had a relatively low wait time compared to where we would expect 3 customers in line to be. So I'm going to say when there are 3 customers, there's an outlier at 3 customers. This is an outlier because it has a much lower, you always want to indicate lower or higher wait time for the number of customers compared to the other. Oh, right. Now, then this last question, I'm leaving it on here just to show you that this is something we are not learning. Calculate 95% confidence interval for the slope. Nope, I will not do that. That is in our last unit, and we are not learning it. It's very easy, but we're not learning it. I do have the video if you wanted to watch it in the document from before. So, all right. Now, let me just show you guys really quick what I want you to do on your Stats Medic Review course. So I'm going to bring this page over here. So first, let's see. What I want you to do right now is the diagnostic test. So some of you might have already done it. If you have, great. If not, there's 2 things I want you to do. Do the diagnostic test. So click this and then do it. It's multiple choice, which your exam doesn't have, but it still gives you a good idea of what concepts you don't know, because the multiple choices will help you kind of get some ideas of what to be studying. There's only there aren't any really that I see that aren't on your exam since they've changed it. So I would just do them all. And then once you finish, what I want you to do is analyze your results. This will be very quick. So click analysis of diagnostic test. Then I want you to print this off, or you do it on your computer or whatever. And what this will tell you is which one of these things you need to study and practice. Which one of these units. I'm going to give you some guidelines for doing all of the units, but this can help you decide which ones to really spend the most time on and work the best in. And so that's that part. And then the last thing is this, I'm going to have a discussion question here for you guys to answer, and I want you to answer it when you do it. And that's just going to be a way for me to know how to help you the best over the next couple of weeks. And then what we'll do after that is I made a schedule for getting through some of the other units before your exam, which, like I said, is May 22nd. And so on May 22nd, you'll take it at 2 p.m. Some of that will involve practicing submitting things online and using the online platform, and then formula sheet, getting ready for the exam, and then just making sure that you were prepared. This review course is going to be your best way to get college credit because it's got a bunch of information in there, and it's all concentrated in one place. And so just keep an eye out for any updates via reminder in Canvas. Follow the schedule, and please email me when you have questions. Make sure all of you email me, Ms. Pendleton, because Ms. Braylon will be out on maternity leave. Thank you so much. I hope you have a great day. Please let me know if you have any questions.